Hello. Hello.
Yes, sir.
Am I audible to everyone? Enough?
Yes, sir.
Yeah.
Enough?
Yes, sir.
I think we have just finished principle of homogeneity, the last topic. It
Yes, sir.
was okay. So we have just explained just one question, P minus A over B square like this. Okay. On the basis of that particular principle of homogeneity, I am defining one more term. If there is trigonometric ratios, suppose sin x, cos x, tan x, or any of the trigonometric function. Similarly, exponential to the power x and log x. In all of these particular terms, here x is nothing but, while this particular x, and this particular x. In this particular trigonometry, this x will represent any angle. And as we have already discussed, angle is the quantity which is dimensionless and variable term. Similarly, this particular x and this particular x in terms of exponential function and in terms of logarithmic term represent nothing but number, and number is dimensionless constant term. So we can define whether these are trigonometric function, exponential function, and logarithmic function. In all of these three situations, x will represent nothing but dimensionless quantity. And for dimensionless, it would be m raised to the power 0, l raised to the power 0, and t raised to the power 0. And as we know, any expression raised to the power 0 will be nothing but 1. Is it clear? So for the case of any quantity which is going to be dimensionless, just equate it to be -1. Now, what we left with? Sin x, e raised to the power x, and log of x, this whole part. This whole sine of that particular angle, e of that particular number, and log of that particular number will define you nothing but any numerical value, and which would also be any dimensionless quantity. So these all three would represent nothing but number, which is also a dimensionless quantity. So we can simply relate this particular term to 1. Okay, so now from this particular part, whether their angle or exponential or this particular number, or whether the whole value, these two will represent nothing but dimensionless. So on calculating the dimension, put it to 1 to calculate the variable part. I'm defining you one example related to define this particular whole concept. If there would be y is equals to a times sine b to x plus c into t. If this is your expression in which x and y represent you displacement, t is nothing but time. And from this, we have to calculate dimension of A, B, and C. So first method is how to approach this particular problem. I'm defining you. The first part is, since this particular is sine, any trigonometric function. As we have just discussed, the sine of this particular x. So x would represent angle, and angle is nothing but any dimensionless quantity. So we can simply see b times x and c times t. These all two terms will define you nothing but angle. So these will be dimensionless quantity. Is it clear to everyone?
Yes, sir.
Yes, sir.
So as we have discussed,
Yes.
for any of the quantity which is dimensionless, we have to just equate it to nothing but 1. Okay, Sabita?
Yes, sir.
So just equate it to 1. We have dimension formula for x and we have to calculate for b. So b would be nothing but 1 over x and x is just length. So 1 over l. If we bring this particular to numerator, it will become l to the power minus 1. Is it clear to everyone?
Yes, sir.
Yes, sir.
Just write it down and try to solve for this particular c and this particular a. Rihab, any doubt?
No, sir.
Nida?
No, sir.
Okay. Shan? And all of you send your answer in chat box. Okay, Shan, just 1 minute. We have just discussed whether it would be trigonometric function, then x would represent just angle. Similarly, for exponential function, x would represent number, and similarly for logarithmic function as well. In either of these three situations, x would be nothing but any dimensionless quantity. And for any of the dimensionless quantity, we put just equals to 1 as They are m raised to the power 0, l raised to the power 0, and t raised to the power 0. And as we know, any number raised to the power 0 would be nothing but 1. Okay, Rishan? Similarly, the whole part, that is sine of x, will represent you nothing but any numerical value. Suppose sine of 30°, it will gives you just 1 by 2. Similarly, e raised to the power x and log of x, these all three would define you nothing but number, and number is dimensionless constant part. So put it to just equals to 1. As we have done in this particular problem, this is your sine. Sine is nothing but any trigonometric function. So bx would represent you nothing but angle. So this particular angle would be dimensionless part. So put this particular bx to 1, and from this we can easily solve this particular b. Okay, Rishan? Good, Avinav. Try to solve for a. Good, Sabita. No, Sabita, it is wrong. Hiram,
So can you show how it is solved?
since this particular c times t is representing angle here, as we have discussed, angle is just nothing but any dimensionless quantity. So we can just relate this particular term to 1. So it would be c times t is equals to 1. T is just time, for which dimension is capital T. So bring this particular term to right hand side, it would be 1 over t. Just write their dimension, bring this particular part to numerator, it will become t raised to the power minus 1. Okay,
Okay.
good, Nida. Is it clear to everyone? Rishan? Abhinav, I'm explaining how to calculate A. Rehav, is it clear?
Yes, sir.
Okay, now, as we have defined this particular part, now this particular whole sine of b times of x and c times of t would be nothing but any numerical value, as I have explained you here. Okay, so this particular whole term will define you any number. And as we know, number is any dimensionless constant part. So just neglect this particular whole part. So what we're left with? Y is equals to nothing but A. Okay, Abhinav?
Yes, sir.
And what is Y here? Y is just
L.
L. So the dimension formula of A would be nothing but L. Is it clear to everyone?
Yes, sir.
Yes.
Umar Abdullah, have you learned this particular concept?
Yes, sir. We did this before.
Okay, okay. Have you all written this?
Yes, sir.
Sabita?
Yes, sir.
Okay. I'm defining one more question on the basis of this. If P is pressure, which is equals to alpha upon beta, and here we have log alpha x divided by energy. In this particular part, P is nothing but pressure. Here E is energy and X is displacement. Just try to find dimension of alpha and beta. How you'd all approach. As we have discussed in last part, log of any particular term, this whole will represent nothing but any number. And as we know, number is any dimensionless constant part. So put this particular part to 1. And from this, as we know for x, x is displacement, and we have dimension formula for energy. So we would be able to calculate dimension formula for alpha from this part. Now, the next part is to this whole log of any particular number will define you nothing but any numerical part. So just neglect this whole and P equated to alpha over beta. We have already calculated alpha from this section, put it to here and simplify it to find beta. Okay, Abhinav?
Yes, sir.
Just try to find all of you. Yes, Rishan, which part? The last question. Okay, just 1 minute. All of you just write this particular question first. Alpha and beta is any alphabet, which is called Greek alphabet. If I suppose I can write A and B instead of alpha and beta, these are not any different part. These are just alphabet in Greek language. As we learn English, first part is to put this particular part to 1, as this will whole represent nothing but any number. Rishan, first put this whole to 1. We have dimension formula for energy and we have dimension formula for x. On that particular equation, try to find alpha. First, try to solve for this. Rishan, first try yourself. Otherwise, I will explain later. Good, Abhinav. Try to find for beta. Good, Riba. Nida, any doubt while solving?
No.
Rehab?
Yes.
Good, Abhinav. Good, Nida. Try to solve for the next part. Sabita, any doubt while solving?
No, sir.
Umar?
Yes, sir.
Good. Okay, Rishan, just see. As we have discussed in the last part, this particular number and this particular whole log of that particular number will be nothing but any dimensionless quantity. So first part is to put this whole segment as they are dimensionless to 1. So alpha into x over E is nothing but 1. As we know dimension formula for energy and we have dimension formula for x. Good, Savita. So on rearranging, alpha would be equals to energy divided by x. Dimension formula of energy would be ml squared t raised to the power minus 2. And x is nothing but displacement, so it would be L. Good, Riba. Nida as well. L and L cancel out, so we're left with ml t raised to the power minus 2. Okay, Rishan? Now it is clear. So we have dimensional formula for alpha. We have dimensional formula for pressure. We have to calculate beta now. So we left with nothing but P is equals to alpha over beta. So beta would be equals to alpha divided by P. Just put their dimension and try to solve. Rehab, send me your answer. Umar, Iram, is this concept clear to everyone?
Yes, sir.
Yes, sir.
Rest of you just send me this particular answer, dimension formula for beta. Ishan, just tell me the dimension formula for pressure. We have already discussed in our last part. Pressure is mL to the power -1 and T raised to the power -2. Just put these two terms in this particular expression and solve. Umar, Rehab, just try to solve once again. There is some error. Aram, any doubt?
No, I'm solving.
Okay. Good, Rishan. Okay, no problem. Umar, have you solved?
Yes, sir.
Just send me your answer. Your previous answer was wrong. Rehab, just see. Alpha is nothing but mLT to the power -2. And P is just pressure, which is ml to the power -1 and T raised to the power -2. We have to just compare each and every part individually. Suppose for first M and N. Similarly for T and T, whether these two would cancel out each other or not. Iram, Rehab,
Yes.
M and N would cancel out each other or not?
They would.
Yeah, so we're left with nothing but M raised to the power 0. Similarly for T as well.
Yes.
So what we're left with? Just L. We have one exponential in numerator and -1 in denominator. So if you bring this particular denominator to numerator, it will become +1, and +1 becomes L squared. Good, Umar. Is it clear, Rehab? Iram?
Yes.
Okay, so we have just finished this particular principle of homogeneity and problems related on this particular concept. Now, next part is application of dimensional analysis. We have mainly three different applications related to this particular dimension. First is check the correctness of any equation, or we can simply say consistency of equation. So if there is expression like half mv squared is equals to mgh, and they will ask you to define whether this particular equation is correct or not on the basis of dimensional analysis. So first of all, try to find dimension for left hand side and try to find dimension for right hand side. If their dimension on either of side, LHS and RHS would equal, we can say this is dimensionally correct equation. Is it clear to everyone?
Yes, sir.
We have. Okay, so first of all, try to find dimension formula for left hand side and similarly for right hand side and check whether they are equal or not. All of you just try to find out. Here m is mass, v is velocity, g is gravity and h is height. And we are aware of all these terms. Ishan, which value? Mass for velocity. Okay. Abhinav, have you solved?
Yes, sir. Doing, sir. Last step.
Okay. Nida, you have to just compare the LHS part and RHS part, whether the dimensions are equal or not. Iram, whether this dimension is for both LHS side and RHS side. Nida, check once again. They should be equal. Diba, mass should be there, I think. When we have solved for left-hand side, LHS, we have half as number, so we can neglect that particular part. M is mass, velocity, LT minus 1 squared. So it will be ml square t raised to the power minus 2. Okay, Nida, you have forgot to write this particular exponential. Similarly, for right-hand side, RHS. Good, Savita. Try to find the dimension for right-hand side, and they would just equal. Just check. Umar,
Yes, sir. From
have you done this?
yes, sir. Done.
Got the same answer on either side?
Yes.
Rehab, send your answer, please. Okay, just see. Similarly, for this particular right-hand side, m is mass, g is gravity, which is nothing but acceleration. So we can write LT to the power minus 2. And h is height, which is also length. So it would be L and L becomes L square. So ml square t raised to the power minus 2. Just compare this particular part and this particular part, whether they are equal or not. Good, Umar. Rishan, just check whether they are equal on left hand side and right side. So these two dimensions are equal. So we can say this particular equation is dimensionally correct. Okay. So just remember just one thing. If any of the equation is dimensionally correct, then the equation may be correct or may not be correct. But if an equation is dimensionally incorrect, it will be wrong always. So why I have just tell you dimensionally correct equation may or may not be correct. If suppose this particular equation is nothing but kinetic energy, and this will be nothing but potential energy. If I change the coefficient of this particular part, Like if I give you 5 times mv square and 3 times mgh, whether their dimension would affect it or not. You may say, no, it can't be affected as we are just changing their coefficient, which are in constant part and which would be dimensionless constant. So their dimension would be equal on this particular segment as well. But the actual equation is this one. So we can write this particular in either of the form. By changing the coefficient, they would show the same dimensions, or they would just define equal dimension on left hand side and right hand side. So we can say dimensionally correct equation may or may not be equal or correct. But if it is dimensionally incorrect, it will always wrong. So the next criteria is how to define the actual formula. It is based on experiment. Is it clear to everyone? So we can simply define a dimensionally correct equation may or may not be correct. But dimensionally incorrect equation is always wrong. Is this statement is clear to all of you? Sabita? Okay, just write it down, all of you. Okay. The next part is, I'm giving you one more problem related to this. If v is equals to root under 3 times p over rho. Here we have v is velocity, p is pressure, and rho is density. Just check whether this equation is dimensionally correct or not. Any one of you who is not aware of the dimension of these 3 terms, please ask me. We have already done this whole part. I'm giving you one hint. While writing this particular square root in terms of exponential, square root is written as half in exponential form. Now just try to find. Good, Nida. Good, Abhinav. Sabita, check your dimension. There is some mistake in the right hand side. Aaron, good. Rehab, have you solved? Umar, send me your answer, please.
Okay, sir.
Rishan, okay, just 1 minute. Riba, have you solved? Okay, just see how this particular term would be done. We have left hand side as velocity. So LHS V is equals to LT to the power -1, as we are aware of this particular dimension. Similarly, for solving right hand side, RHS, we have square root. So we can write whole to the power half. 3 is any constant part, so we can neglect it. piece pressure having dimension ml to the power -1 t raised to the power -2. Here we have density. Density is nothing but mass upon volume, or dimension of this particular part would be ml to the power -3. Is it clear to everyone? Now just solve. M and M would cancel out. We have L raised to the power -1 in numerator, good riba, and L raised to the power -3 in denominator. While bringing this particular to the numerator, it will become +3. So we're left with L raised to the power 2 and T raised to the power -2 and whole to the power half. As we all know, the rule of exponential, if x raised to the power m and raised to the power n, so the power would get multiplied. So by the same rule, it would become L square into power half and t to the power -2 into half. This 2 and this 2 would cancel out. This 2 and this 2 would cancel out. So we're left with L raised to the power 1 and t raised to the power -1. Now just compare LHS and RHS, whether they are equal or not. Iram, oh, you have done correct. Rehab,
Yes, sir.
is it clear?
Yes, sir.
Okay, all of you have written this?
Yes, sir.
Yes.
Okay, then we'll just stop here. I will continue the next, that is conversion of units from one to another and deducing relationship in our next class. Okay, just try to revise all this whole topic and try to solve all these problems on your own. Okay,
Yes, sir.
okay then,
Thank you, sir.
thank you.
Thank you.
Thank you, sir.
Okay, thank you.